Welcome back to the Deep Dive, your shortcut to being well-informed.
Great to be here.
Today, we're looking at something I think a lot of us wonder about: how to jump higher, run faster, just get more explosive.
Absolutely. That desire for peak performance is pretty universal.
And it often feels like you need huge changes, but sometimes it's the smaller tweaks, right?
Exactly. Small changes in how you train can lead to surprisingly big results.
So today, we're taking a deep dive into an exciting new study. It compares two pretty cutting-edge training methods.
Both designed specifically to boost vertical jump and strength.
Our mission today is basically to unpack these methods, figure out how they work, and help you understand which one might be a good fit.
Maybe even a game changer for your own goals.
So where does this deep dive come from? What's the source?
Right. This is based on a research article titled Accentuated Eccentric Loading in Countermovement Jumps vs. Drop Jumps. Effects on Jump Performance and Strength in a Randomized Controlled Trial.
Okay, that's a mouthful.
It is. It was published just this year, 2025, in the Journal of Sports Science and Medicine. Volume 24, pages 20 to 30.
And the authors?
The lead author is Zhengqiu, working with a pretty large team from several institutions: Shanghai University of Sport, London Sports Institute, Cardiff Metropolitan University, and others. A real international collaboration.
Good stuff. So what can people expect to learn as we walk through this?
Well, we'll break down what these training methods actually are,
Okay.
how the researchers set up the comparison, what they found the results.
The important part.
Definitely. What it means for improving jump and strength, and also where these methods might not be the whole answer.
Okay, great. Let's start with the basics then. We hear lower body explosive power all the time. Crucial for basketball, sprinting, you name it. But scientifically speaking, what is it? Why is it so fundamental?
Basically, it's your muscle's ability to generate maximum force really, really quickly in the shortest time possible.
Like a quick burst of energy.
Exactly. It's the engine behind those fast, powerful movements. And a huge part of that comes from something called the stretch-shortening cycle, the SSC.
SSC.
Think of stretching a rubber band really fast and letting it snap back. You store energy when you stretch it,
Right.
and then you get this explosive release. In our muscles, that's a rapid eccentric contraction. That's the muscle lengthening, the stretch.
Okay, lengthening.
Immediately followed by an explosive concentric contraction, the muscle shortening, the snapback.
Okay, lengthen, then shorten, fast.
Precisely. And that cycle lets you generate way more power than just shortening the muscle alone. It's absolutely key for jumping.
That rubber band analogy really helps, makes total sense. So how did this study measure that explosive power? They used specific jumps, right?
They did. They focused mainly on two common ones: the counter-movement jump, or CMJ, and the drop jump, DJ.
CMJ and DJ. Can you describe those quickly?
Sure. For CMJ, you start standing, dip down quickly like a mini squat, and then immediately explode straight up. It's, a pretty natural jump.
Yeah, I can picture that.
The drop jump is different. You step off a box or platform,
Okay.
and the instant your feet hit the ground, you jump up as high as you can. The landing itself kind of preloads the muscles eccentrically.
Right, the impact does the loading. And this study is focused on deliberately boosting that eccentric part in the counter movement jump, the CMJ.
Exactly.
Yeah.
Using something called accentuated eccentric loading, or AEL.
AEL. Okay, what is that? How does it work with the CMJ?
So AEL is a technique where you deliberately increase the load only during that downward eccentric muscle lengthening phase of the jump.
Only on the way down.
Right. Imagine holding extra weights as you dip down, or maybe having resistance bands pulling you down. But then, and this is the key bit, that extra weight or resistance is removed right before you start pushing up.
So you load heavy going down, but jump up light.
Exactly. Your muscles handle a much bigger load eccentrically, but then they explode upwards concentrically with just your body weight.
Okay, that's different from the drop jump then.
Very different. With the drop jump, the eccentric load comes from the impact of landing from a height, and you jump up, still managing that impact force. AEL isolates the overload to just the downward phase.
That feels like a really important distinction, maybe especially for safety.
Potentially, yes. Drop jump training works, no doubt. It's been used for ages.
Right.
But it definitely carries a higher risk of injury because of those impact forces. Shin splints, knee issues, things like that.
Okay, so AEL CMJ is kind of emerging as maybe a safer way to get similar benefits.
That's the idea, or at least the question researchers are asking. It's getting a lot of attention. So this study basically set up a head-to-head comparison.
The old champ versus the new challenger.
Kind of. can AEL-CMJ deliver the same punch as DJ training, but maybe with less risk? What did the researchers think would happen?
What was their hypothesis?
They predicted that AEL-CMJ training wouldn't just improve strength and jump performance, but also things like sprinting and changing direction. And crucially, they hypothesized that the effects would be very similar to drop jump training across the board, essentially asking, can we get the DJ benefits maybe more safely with AEL?
Okay, a critical question. To test that, they needed a solid study. Who participated? Who were the subjects?
They recruited 40 male physical education students. Average age was around 22, 23 years old.
So, young, active guys.
Exactly, and not beginners either. They had to have been training consistently at least twice a week for 2 years minimum.
Okay.
Plus, they needed a decent strength base, had to be able to squat at least 1.5 times their body weight. And, of course, no current injuries.
So, a pretty fit, experienced group.
Yeah.
And the study design itself, a randomized controlled trial, right? The gold standard.
That's right, RCT. They randomly put these 40 guys into one of 3 groups.
Okay, what were the groups?
You had the AEL Group 14 guys doing the accentuated eccentric loading CMJs.
Group 1.
Then the DJ Group 13 guys doing the traditional drop jump.
Group 2.
And finally, a control group. Conan, another 13 guys who just kept up their normal routines, no specific jump training added.
Right, and randomization is key there.
Absolutely. It helps ensure the groups start out as similar as possible, so any differences you see at the end are more likely due to the training itself, not just who ended up in which group.
Makes sense. So, what did the actual training involve over the 8 weeks for those AEL and DJ groups?
Okay, so it was an 8-week program. They trained 3 times per week.
3 times, okay.
Yeah, with at least 48 hours rest in between sessions. Importantly, a coach supervised everything.
Good. And the number of jumps, did that change?
It did. For the first 4 weeks, both groups did 32 jumps per session. That was structured as 4 sets of 8 reps.
2 sets of 8.
Then for the last 4 weeks, they bumped up the volume to 40 jumps a session, 4 sets of 10 reps.
Okay, progressive overload.
Exactly. And here's a really critical detail. The intensity was individualized for optimal power.
How did they do that?
For the AEL group, they figured out the optimal load, like adding maybe 10% of the person's body mass via weights or bands that allowed for peak power output during the CMJ.
Okay, tailored load.
And for the DJ group, they found the optimal drop height starting around 30 centimeters, maybe adjusting down to 20 centimeters mid-study based on testing again, the height that allowed that specific person to generate the most power on the jump.
Wow, so really customized to each person.
Yes, that individualization is super important for getting the best results from power training, not just a one-size-fits-all approach.
Okay, solid setup, individualized training. Now, the payoff, the results. What exactly did they measure to see if it worked?
They used a whole battery of tests. For jump performance, they measured height and power in both the countermovement jump, the CMJ, and also the squat jump, or SJ. That's a jump from a static squat position, no prior dip.
Okay, CMJ and SJ. What else?
Lower body strength. They tested the 1 repetition max, the 1 RM on the back squat.
Classic strength measure.
Yep. Then speed, a 30-meter sprint time. And finally, agility, or change of direction ability, using something called the T-test.
T-test. Got it. And they measured all this when?
3 times. Before the training started, that's baseline. Then halfway through, at 4 weeks.
Midpoint check.
Right. And then again, right after the full 8 weeks of training finished. This lets you see not just the final outcome, but also the progression.
Okay. Baseline, mid, and post. All right, let's dive into those findings. What did the data actually show after 8 weeks?
Well, this is where it gets really interesting. The overall picture was pretty clear.
Yeah.
Both the AEL, CMJ training and the DJ training were effective. They significantly boosted vertical jump performance and lower body strength after the 8 weeks.
Okay, so both methods worked.
Yes. And crucially, they had very similar effects. The improvements were comparable between the 2 groups.
Wow, okay. Similar results from different methods.
Yeah.
Anything else stand out?
2 other key things. First, neither training method made a significant difference in sprint times or the change of direction test results.
Okay. No speed or agility gains.
Right. And second, there were no significant improvements in any of the measurements after just the first 4 weeks.
Yeah. Nothing at the halfway point.
Nope. It seems the full 8-week duration was necessary to really see these adaptations take hold.
Fascinating. Okay, let's break down those jump improvements. You said both groups got better. Similarly, can you give us some numbers?
Sure. The AEL group, they saw their CMJ height go up by 11.8%. That's statistically a moderate effect size, which is quite meaningful in practice.
11.8%. Yeah, that's noticeable.
Their squat jump height also went up by 5.7%, small effect, but still significant, and big improvements in power output for both jumps too.
Okay, good gains for AEL. What about the drop jump group?
A very similar story. Their CMJ height improved by 7.7%, a small effect size, but still solid. And their SJ height went up by 11.3%, a moderate effect there, plus significant gains in power for them too.
So both groups clearly improving their jumping ability. And the control group.
As expected, the control group showed basically no significant changes. Maybe tiny fluctuations, even slight decreases in some things. It really highlights that the improvements were due to the specific training.
Right. And what about raw strength? The squat 1RM.
Both training groups got stronger there, too. The AEL group increased their squat max by 7.0%.
Okay.
And the DJ group increased theirs by 8.4%. Again, statistically, these are considered small effect sizes for strength over 8 weeks, but definitely positive changes.
And the control group again?
No significant change in strength for them.
Okay, so clear wins for jump height, jump power, and squat strength for both AEL and DJ groups.
Correct.
But let's go back to that finding about sprinting and change of direction. Why didn't those improve? It seems a bit counterintuitive, right? More explosive legs should mean faster running.
You'd think so, wouldn't you? But it really highlights the principle of training specificity. Meaning your body adapts very specifically to the type of stress you put on it. The researchers suggested a few reasons for this lack of transfer.
Okay, like what?
Well, first, vertical jump training is vertical. Sprinting and changing direction involve a lot more horizontal force production, different movement patterns.
Okay. Up versus forward.
Exactly.
Yeah.
Second, the training goal here was maximum height on the jump, not necessarily maximum speed of movement, which could lead to different neuromuscular adaptations.
Interesting.
Also, sprinting involves what's called a fast stretch-shortening cycle. It happens very quickly, relies heavily on tendon stiffness. The jump training might have been more of a slow SSC, relatively speaking, leading to different adaptations.
Fast versus slow SSC.
And finally, for change of direction specifically, the training volume, the number of jumps per session, might just not have been enough.
Not enough reps.
Possibly. Other studies that did show improvements in agility using plyometrics often used way more reps per session, sometimes almost double what was done here, like 48 to 72 jumps compared to the 32 to 40 in this study.
Okay, that makes sense. Specificity and maybe not enough volume for those other skills.
That seems to be the most likely explanation based on the discussion in the paper.
And you also mentioned that crucial point about the timing. No gains at 4 weeks, only at 8. What's the takeaway there?
It really underscores that physiological adaptation takes time. You need patience and consistency.
Yeah.
Those first 4 weeks were likely laying the groundwork, neurologically and within the muscle tissue itself. The visible performance improvements needed that full 8-week stimulus to really kick in.
So stick with it. Don't expect miracles overnight.
Pretty much. Consistent effort over a sufficient period is key.
All right, we've got the results. Now let's get into the so what. Why did these jump and strength gains actually happen? What's the mechanism behind it?
If we connect it to the bigger picture, the improvements seem to come from a mix of changes in both the nervous system, how your brain controls your muscles, and changes within the muscles themselves.
Okay, neuro and muscular.
Right. Neurologically, both methods likely improved how well you use that stretch-shortening cycle, storing and releasing elastic energy more effectively, like improving the spring.
Better rubber band snap.
Exactly. Plus, they probably increase motor unit recruitment and firing rate. Basically, your brain sends stronger, faster signals to activate more muscle fibers.
Okay, better control.
And then within the muscle itself, there's likely an improvement in the muscle's intrinsic ability to produce force, and particularly with the accentuated eccentric loading.
The AEL.
Yeah. That heavy eccentric phase can cause tiny amounts of muscle damage. That sounds bad, but it's actually a stimulus for repair and growth, a process called hypertrophy. So the muscles might actually get a bit bigger and stronger over time. Though hypertrophy wasn't directly measured here, it's a known effect of eccentric training.
So better nerve signals, better energy use, and potentially stronger, maybe some slightly bigger muscles, a combination effect.
That's the current understanding, yes. Both neurogenic and myogenic factors contributing.
It's still fascinating that AEL, CMJ, and DJ training produce such similar results, given how different the loading feels? What does that similarity tell us?
I think it strongly points back to that individualized intensity we talked about.
The optimal loads and heights.
Exactly. By carefully tailoring the load for AEL and the drop height for DJ to match each person's optimal power zone, the researchers likely equalized the effective training stimulus, even though the methods look different.
So it's not just the method, but hitting that sweet spot of intensity.
Precisely. It supports the idea that optimal loading, whatever the method, is really key for maximizing power development.
Okay, so let's translate this. What are the practical takeaways for people listening? Coaches, athletes, maybe just fitness enthusiasts?
Well, the big takeaway is that you've got two effective tools here. Both AEL-CMJ and DJ training work well for improving vertical jump and lower body strength.
And they work similarly well.
Yes, yielding comparable improvements based on this study. That gives coaches and athletes choices.
But there's that safety aspect we touched on earlier.
And that's where AEL-CMJ might have a real edge. This raises an important practical point. Given the known risks associated with drop jumps, the higher impact forces.
Right.
This study suggests AEL-CMJ could be a genuinely safer yet equally effective alternative.
That seems huge, especially for certain people.
Absolutely. Think about athletes coming back from lower leg injuries, or maybe younger athletes whose bodies are still developing, or even just people who find high-impact landings uncomfortable. AEL provides that eccentric stimulus without the same level of impact stress.
So a potentially powerful tool with maybe a better risk-benefit profile for some.
That's certainly what the evidence here suggests, making it a very attractive option to consider.
Now, like any research, this study isn't perfect. The authors acknowledge some limitations, right?
They did, which is good scientific practice. They mentioned that even with randomization, there's always a small chance that some subtle differences between the groups at the start might have slightly influenced the results.
Okay. Unavoidable, maybe?
Pretty much. They also pointed out the lack of long-term follow-up. We know the effects after 8 weeks, but we don't know if those gains stick around for, say, 6 months or how they change over time without continued training.
Right. Durability of the effect.
Exactly. And one other thing was the lack of continuous intensity monitoring during the 8 weeks. While the loads and heights were set individually at points, they didn't track if maybe someone got stronger midway and needed an adjustment between the formal tests. So maybe not everyone got the absolute perfect stimulus the entire time.
Minor point, perhaps, but worth noting. Despite those limitations, it's still a valuable study. Did the researchers suggest where future research should go?
Yes, they had some interesting ideas. One was to explore combining both methods.
AEL and DJ.
Yeah, maybe alternating them or using them in the same program. Could that provide an even bigger boost? A synergistic effect? That's an open question.
Interesting.
They also suggested more research into finding complementary training methods, things other than vertical jumps that could specifically target and improve that sprint speed and change of direction ability, since these jump methods didn't seem to do it effectively on their own.
Right, finding the missing pieces for speed and agility.
Exactly. Addressing those gaps identified here.
Okay, let's try to wrap this up then. Key takeaways for everyone listening.
Sure. I'd say number 1, 8 weeks of either AEL, CMJ, or DJ training works. It significantly boosts vertical jump and squat strength.
And number 2, the effects are pretty similar between the two methods.
Correct. Number 3, neither method, at least as performed in this study, seemed to improve 30-meter sprint time or T-test agility scores.
Specificity matters.
Very much so. And number 4, don't expect results overnight. The gains really showed up after the full 8 weeks, not at the 4-week mark. Consistency is key.
Got it. Powerful takeaways. Any final advice for coaches or athletes based on this?
I'd say for practitioners, this study confirms you have 2 solid, comparable options for developing jump power and strength.
But consider AEL carefully.
Yes, especially if injury risk or impact tolerance is a concern, AEL-CMJ looks like a very promising, potentially safer alternative that delivers similar results. Definitely worth exploring.
And if people found this fascinating,
Oh, absolutely. Read the full paper. Guy and the team provide all the detailed data, the methods, the statistical analysis. It's really well laid out in the Journal of Sports Science and Medicine.
great recommendation. And of course, if you listening want more deep dives like this one, breaking down research into practical insights,
Make sure you follow the channel.
definitely turn on those notifications so you don't miss out on getting well informed with us.
So here's a final thought to chew on, building on this.
Oh, okay.
Considering these findings about eccentric loading for vertical power, What other specific areas of athletic performance do you think could really benefit from a similarly targeted eccentric training approach? And maybe more importantly, how would we best design a study to actually test that impact effectively?
Applying this concept beyond just jumping. Interesting question.